In this 12th century world map, south is placed at the top. Turned around 180 degrees, it shows the Arabian Peninsula in the center and Central Asia to the right. Here lies the empire of Tamerlane and his grandson, Ulugh Beg, who made Samarkand his capital. On the left side of the main square lies the Ulugh Beg Madrasa. Jiyat al-Din Al-Kashi lectured here, the famous astronomer and mathematician who died in 1429. His colleague, Al-Rumi, the mathematics teacher of Ulugh Beg, was the first headmaster of the school. To calculate the volume and surfaces of a dome like this one, or of an arch, Al-Kashi described 5 constructions using only ruler and compass. They provide an approximation for most arches and domes. The diameter AD equals the span of the arch. Arcs are drawn from the center E, as well as from the points H and Z. And the perpendiculars SN and ON are erected. These 5 sections together form the facade of the arch. Top right and left are the spandrels. The lower blue segments could be situated inside a wall. Given depth, the facade becomes an arch, or a vault if the depth exceeds the span. When turned around its axis, a dome is generated. The smaller dome of Al-Rumi's mausoleum matches the first construction. Diameter AD is again the span of the arch. Extended to I and M by the thickness of the arch. CA is moved parallel down to EH in the extension of EG. We draw arcs from the center E as well as from the points H and Z. And we erect the perpendiculars SN and ON. These 5 sections form the facade of the arch. An example is the dome of the Madrasa Tilakari on Samarkand's main square. We make EC perpendicular and equal to AE, and EB equal to 1/8 AE. CA is moved parallel down to BH, and extended till point G. We describe from point B arc DG and arc ML, and from point H arc GT and arc LO. In point O, we erect the perpendicular NO. Half of the arch is now completed. The second half is the same. The dome of the Mosque Qalian in Bukhara, a stork's nest on top, gives us an example. We divide the span AD in 3 equal parts through B and Z. Arcs are drawn from B and Z. With AK and DL the thickness of the arch. We erect the perpendiculars HN and IN. The 3 sections form the facade of the arch. The dome of the Gur Emir mausoleum of Tamerlane and Ulugh Beg approximates this example. On the 2 ends of the span AD, we erect the perpendiculars DZ and AG equal to AD. And we describe from the points G and Z the arcs DT and AT, with the diagonal AZ as radius, as well as the arcs IH and BH. Thus we obtain the facade of the arch. Examples are the 4 towers of the Kha Minar in Bukhara. These 5 constructions were designed as aids to calculation. We use them to build a Qubba for Al-Kashi. The Arabic word Qubba means both dome and mausoleum. Al-Kashi certainly deserves a mausoleum, being one of the greatest Islamic scientists. Inside the Qubba, we see Al-Kashi's tomb. The lower walls consist of slabs of marble. Above these, decorative tiles surround the arches. The interior dome is richly decorated with gold foil. The decoration is borrowed from the Madrasa Tilakari. Al-Kashi's methods were useful for appraising both the necessary amount of gold and the requisite manpower. As in Al-Rumi's Qubba, there is more than one tomb. The exterior windows also exist in a real building, in the Madrasa Khirdar, facing the Madrasa Ulugh Beg on Samarkand's main square. The Qubba lies near the observatory where Al-Kashi died. Al-Kashi was the founding director of the observatory and supervised the construction of the instruments. He describes these instruments in a letter to his father. In the same letter, he praises Ulugh Beg as a scholar and speaks with disdain of some of his fellow scholars who do not know the Almagest. The main axis of the observatory is the sextant, situated north-south along the meridian. Sunlight enters through the aperture at the top to measure the solstice and the equinox. The measurements were used to determine the local latitude and the obliquity of the ecliptic. This instrument is known as a Fakhri sextant. It was invented around the year 1000 in Rey, near modern Tehran. The radius of the sextant measures a little over 40 meters. The subterranean part is 11 meters. According to contemporary sources, the outside of the observatory was richly decorated. They also relate that the observatory was 3 stories high. Entering on the north side, we find astronomers at work and see their instruments and manuscripts. The Jai Singh Observatory in New Delhi was built after the Samarkand Observatory. The Samarkand Observatory was destroyed in the 16th century. Only part of the sextant remained, and the ruins of the foundations. The circular walls of the observatory contain a diameter of about 48 meters. The arcs of the sextant contain division marks for each consecutive second from 19 to 80 minutes. The marks between the numbers 80 and 57 are still in their original places. With Al-Kashi, Samarkand became the most important scientific center in the East. Ulugh Beg's research staff made observations for over 30 years. The results were laid down in astronomical tables, the Zij Ulugh Beg. This Zij includes actual tables of calendar calculations of trigonometry and of the planets. And they contain a star catalogue with 1,018 fixed stars. The fixed stars were important in practical astronomy, for orientation on sea and in the desert, as well as to fix the seasons. The star catalogue was partly based on Al-Sufi's catalogue of the 10th century. Here we see the constellation Orion, taken from an Al-Sufi manuscript.